Good evening, everyone. Welcome back. We will continue with our Kubernetes session. So today is Kubernetes day 10 session. And today the date is 26th of your March. And the timing is evening 8:36 p.m. IST. Okay, guys. So let us continue our class, guys. So before we get into today's session, let us see what we did on day 9. Day 9, if you see it, we majorly did on the label, right? What are Kubernetes label? So Kubernetes labels are nothing but labels are very important because labels comes under the metadata. Whenever we want to query any information about the pod, we basically query with the help of a label, right? And it is very important that always we assign some label whenever we are creating a pod. Okay. By default, what happened? The pods will when the pods are getting created, Kubernetes will assign some default labels. But apart from that, we also assign many other labels, right? In the last session, if you have seen that, we have assigned the label, and the labels comes under the metadata section. Correct. Apart from that, guys, we also discussed something on selectors and annotations. These are something which we just discussed, but I think we didn't really work much on it because selectors are something which comes as a part of the service. When I cover the service part, right, at that time you'll see that mostly we'll be discussing on selectors. Annotations also I had discussed from a very high level, and some of you ping me separately in the WhatsApp group, and you are, guys asked me that sorry, you told me that you didn't understood about the annotation, guys. See, annotations are same like a metadata. Like I think in some example I have written that also, right? Yeah, this is what annotation. Annotation is same like a label which comes under the metadata, right? So labels are the one which are recognized by your Kubernetes object. Means that Kubernetes, whenever you want to refer it, any information metadata, it can even refer to the labels. But whereas an annotation is something which are not, or we can say which is a non-identifying metadata. It means that your Kubernetes object or Kubernetes doesn't identify this annotations actually. Annotations also same thing. It's like a key and a value pair where you are passing some information. But where exactly you might ask Rajesh, when you are trying to use selectors, do we use annotations or we use only labels? Whenever we are coming with the selector part, guys, we always use labels, not the annotations. Okay, that is one part. Well, that is one thing. And the second important thing, that annotation, as I said, it's a non-identifying metadata stuff that is not at all used internally by your Kubernetes. Okay, but where it is used actually, so they are used by some external tools or libraries. For example, I told that annotations are majorly used by some external tools. Like for example, annotations are used by what is it, external tools and libraries. So uh, for example, like you remember, like these are the annotations which I have mentioned. Say for example, like you want to get all the metrics details about your pod. Like for example, your pod, if it utilizes certain memory and the CPU cycles, right? So whatever the CPUs and the memory metrics, if you want to capture it actually, metrics, you need to capture from the running pod. So basically what you guys, basically like you will have a Prometheus as a sidecar container. You will make it to run inside a pod, and that sidecar container, that Prometheus is right container, will try to get the information from the main container. Main container means your application container. Like for example, here suppose assume that you are having a pod like this. So guys, today we will be getting into introduction to the pod, but I'm just saying that if you're having a container, sorry, if you're having a pod, consider this is a pod. And here what happened that you will be running some application here. Like for example, you might be running some Java application or some Python applications. Consider that you're running a Java app actually. And you need to find out all the metrics like CPU metrics and the memory utilization by this container, right? So what we do basically, like, we will try to have one more one more sidecar container we're going to create. Like this will act like your Prometheus, which will try to take a metric information from your Java app actually. Now, the thing is that when you're trying to start this Prometheus container inside a pod, inside the same pod, then in your Prometheus, it might need some metric information. Like, for example, it might need that on which port number it has to get the information. Okay. What are the metrics actually, right? What are the, I can say that the complete REST API endpoint through which I can get that metrics. All those information, it is going to get through the annotations actually. You could see that prometheus.io/path. You could see there's something like slash metrics. Yeah. So this is actually the endpoint. We can say that where through which it can get the information about the memory utilization and CPU utilization like this. So similarly, like onto which port number what happened, right? Those information you're going to get it. You're going to get the information through port number 1902. Right. So these are some of the metrics, guys, which would be used by your external tool. So here in this case, the external tool is a Prometheus actually, right? Prometheus is a monitoring tool. And for Prometheus to run, it needs some configuration. That configuration we are passing as a part of annotations. So that's what I just said, right? Like these annotations are used by some external tools or libraries only. It is not internally used by your Kubernetes actually. Kubernetes never use annotation. It only uses the labels meta information, right? Whatever the labels you're passing, right, as part of it, only that is only used by internally by your Kubernetes object, right? So that's how guys actually like see, I mean, if you want to really understand about more about this, like for example, you know that nowadays, like whenever we are building any applications, right? Like for example, when we are building an applications, basically most of the applications which you are building, which we are developing today, most of them are microservices, right? All those are microservices. And like microservice, and you can take any language to build this microservice. Like for example, you can take Java, you can take Python, you can take Go language, you can take any language to develop these microservices or the applications we say. But all these applications which are developed today, most of them are REST APIs, right? Most of them are REST APIs. For example, if you are developing some application like something like www.mywebapp.com, like this is your application. This is the application URL which you have designed or developed it, right? So this application. Now, for example, you want to check the health of your application, right? So how do you do it? Actually, basically, when you are developing the application, basically we develop the REST APIs and we try to add on one more path, like something like health, actually, like that health Z, something like this. So whenever an end user is hitting this URL, basically what happened, this URL is going to return some kind of a very normal or a basic kind of a JSON format it returns actually. Okay. So when you're trying to hit to this URL, complete URL with the slash health. So what happened? Your whole application is not loaded, right? But whereas what happened, right? When you're trying to give this the endpoints, that is slash health endpoint, if we are trying to provide it when you are trying to hit this API. So what the application knows that, okay, the application will know that, okay, the user wants to get the information about the health check of this application which is running. So basically what happened, as a part of executing this endpoint, what it returns, basically it returns the very basic or a small JSON data it returns, where what happened, it will give you the status information saying that, okay, the status code is 200. It means that this application is working fine, right? And also it gives you the something status, that is the return status. You can say that that is the return code. Return status or code is something 200. And also it will give you some information about status that your application is up, something like this, right? So now, for example, the same developer, when he is trying to develop the API with something like mywebapp.com/metrics, something like this. So whenever the end user is trying to hit to this API, so this is nothing but an endpoint. Slash metric is an endpoint, right? So what it will return, guys? It is going to return you some information, or it's going to return the JSON format data, right? In that JSON format data, you are going to get the information like what is the CPU utilization which is being accessed by, or which has been used by your application, as well as the memory. So this is something like we call this as these are the endpoints which usually developer, when they develop it, right, they try to add this all these endpoints actually. Am I clear, sir? So similarly, you know that actually that whenever you want to log into the application, right, basically what happened, you will give the complete URL, like for example, facebook.com/login. You know, guys, when you try to give this complete URL, basically what happened, you remember, right? Basically what happened, that you're going to get a page where, like it'll ask you to give some details like username. It'll ask you for the password. It also gives give the email ID, any one of the email ID, either Gmail or Hotmail. You try to give a Gmail account name, email ID. You give your username and the password. Sometime it might ask you for giving probably your date of birth or something like that. Then you will activate your account. So that is a login page actually. Right? Login, no, not login page, sorry. It is a, what is it? Sign up page, sorry. Sign up page. Once you have signed up, actually, once you have signed up an account, then whenever you want to log in, it basically what you do, that you try to do a www.facebook.com. If you try to hit to this URL, it'll redirect to the /www.facebook.com/login, right? So what happened? There will something like a redirection will be there, right? Like 301, right? Which is the code, HTTP code used for your redirecting the URL, right? So when I try to whenever I try to use it, whenever end user is trying to give facebook.com or something, he will try to do www.fd.com. If you try to hit these URLs in his browser, basically what happened, guys, he is going to redirect to the facebook.com/login actually, right? That is a page where he can give the username and password and he can log in it actually. So these are the endpoints which are been designed actually. Am I clear, sir? Right? So
Yes, yes.
yeah. Now what happened, right? These endpoints, what happened, right? Whenever you want to pass it for your application, you can pass it through with the help of your annotations like this. So slash matrix is nothing but it's an endpoint. So you are saying that from Prometheus is that whenever it want to get the information matrix, so where it can get this information about this matrix, and all, it will get everything information from the annotation itself. Am I clear, sir? Okay, good. Now, so that's all about the annotation. We will see more examples, guys, in our upcoming session when appropriately, like when I'm covering a certain topic, right? There I have to explain you about, like, for example, health monitoring. That's what, like Kubernetes health monitoring, right? When I'm trying to show the integration of Prometheus and Grafana with the Kubernetes pod, right? At that time, I have to show all this. I have to use these annotations to show you how these annotations is used as a configuration for your Prometheus container, right? Okay. Now, guys, fine. What will be the today's topic actually? So today we will be starting with the introduction to the pod actually. All these days we have been hearing a lot about the pod, right? But we don't know exactly what is pod is all about. So let us try to understand in today's session what exactly pod is all about, right? So guys, we have been hearing a lot about the pod definition, that pod is a smallest deployable unit in Kubernetes. We call it as a pod, right? It's the smallest deployable unit is called as a pod actually. Now, whenever we want to run any application, or we call it as a microservices, we can run that microservices or your application inside a pod actually, right? So whenever application, whenever the user want to run the microservice, or we call it an application, uh, in the Kubernetes cluster. So basically, there is a Kubernetes object, or you can say Kubernetes resource by name pod, by the name pod pod. So using the pod resource, the Kubernetes, or you can call it as an API server, will create a new pod. So it means that as soon as a pod get created, this is the pod, consider this is a pod. As soon as a pod will get created, inside a pod, a container will be created actually. A container will be created, and this container, inside this container, what happened, right? Inside this container, that app or your application that image or application will be running. App will be running in the inside the container. So it means that always remember, guys, whenever you're having a pod, so inside a pod, this is a pod actually, we say. Inside a pod, a container will be created always. Now the question comes that which container technology we're using, right? There are so many container technologies are available, right? For example, like we have a container technology like Docker is there. We have a container technology like Container D, which is a very lightweight containerization technology. We have a Rocket. We have a Podman. It depends upon the user requirement. He can choose any one of this container technology. Like in Linux, we have something like a LXs. LXs, Linux lightweight containers, we say that we call an LXs actually, right? So you can even use LXs also. Now the point here is that actually that which content technology we can use. You can use anything. Suppose if you're trying to create a if you're trying to use a Docker with your Kubernetes, like for example, you know that when we try to install the Linux, when you try to install the Kubernetes, we can choose any one of this content technology, right? Because without the content technology, your Kubernetes cannot work because ultimately what happened is whenever you're trying to run any kind of an application inside your Kubernetes cluster, a pod has to get created. And inside a pod, what happened, right? Your application cannot just run inside a pod because inside a pod, a container has to be created. And that container will like where your application will be running or where your microservice application will be running. Am I clear, sir? So this container which is created, right? This could be any one of this. It could be Docker, it could be container, it could be Rocket, or it could be Podman, or any other technology which is available. So right now, guys, in our Kubernetes cluster here, like which I have it actually, in both this master node and the worker node, I have installed a Docker actually. I have installed a Docker. So it means that whenever the Kubernetes is going to create a pod, inside a pod, what happen? A Docker container will get created. This is nothing but your Docker container. Suppose you have installed the container D, then the container D container will get created actually. Right? So now, so like you can say that, okay, Rajesh, when you are running a pod actually, it means that inside a pod, a container get created. Yes. Now what would be running here inside pod? An application will be running. But what is that application form or what is the format? The application format is, it's an image format only. Like whatever we try to go and deploy into your Docker container, right? Like because we need to have an image, right? Correct, guys. You need to have an image where what happened that with the use of that image itself, you can able to load that. You can able to run that application inside a container. So that format is not, but it is an image format actually. It's a Dockerized image format, and that Dockerized image format, what happened, right? That has to be pulled and it has to be run inside this Docker container. Now, the thing is that, guys, actually that when we know that actually that whenever we are trying to have an application which has to be run inside a container, we know that like we have to choose some technology like Docker. If I use it as a container technology, we know that always whenever you want to build an image or we want to build any microservice application which has to run inside a Docker container, it has to be in an image format. Right? It has to be format. So what we do basically, guys, we try to write a Docker file, and that Docker file can be used to create an image, and that image, whatever the image which you have created, right, that has to be placed in some kind of a registry. It could be a public registry or it could be a private registry, right? You can place your image anywhere actually. So usually what happens, the organization, they try to keep all this registry, they try to keep all this image information in some private registry. They don't want to keep it in public registry, right? Public registry is something like hub.docker.com, where what happened, right? You can keep all your image, everything into the public registry or a public repository. Usually we don't do that actually, but we can have your own private registry within your hub.docker.com. And then like you can have all your images which you have built as a part of day-to-day activity, right? You can able to keep it over there. Either you can keep it over there, or else you can keep it in your Elastic Container Registry, ECR, we say, which is in AWS. In Azure, we have something like ACR, right? There are many other are there. Like for example, you have a JFrog Artifactory. We can use it, right? We can even use the Nexus Artifactory also. Like that, there are many artifactories are available, guys, where you can keep it all your image. Now, when you're keeping all this image in this registries, basically what happened when you try to create a pod, or whenever the Kubernetes master node, or nothing but your API server, when it is trying to create a pod, inside a pod, what happen, a container will get created. And that container, what happened, right? In that container, an image has to be pulled and it has to be run actually. So basically what happened, the image will be pulled from any of this registry. Either it could be a public registry or private registry. Most of the time it will be a private registry, from where what happened, right? That image will be pulled inside this, and then like the application will start running inside this Docker container, right? And this container will be inside a pod actually. Now, what is a pod basically? As I said, that pod is a smallest deployable unit in your Kubernetes. Yeah, it means that, okay, whenever you want to run any application, you have to have a pod. Okay, right? And what happened, right? This pod, what happened? A pod will get created. It is something like it is an outer layer, right? Or nothing, but it's like a wrapper. Inside this wrapper, a container will be running. And whenever a pod will get created, right? A pod will get created. Basically, what happens, guys, the pod will have its own namespace actually, right? It has its own namespace. Like, for example, you have a, so pod, firstly, what happened, right? Whenever a pod get created, pod will be created, okay, in some worker node, right? Because basically, whenever a pod is getting created, it never gets scheduled in the master node unless and until you specifically explicitly you mention that, okay, the pod can be created in master node, but otherwise, most of the time, what happens, the pod will never get created in a master node. It will just created in your worker node itself, actually, right? And in that worker node, guys, there is something known as a kubelet. Actually, this is like an agent which will be running inside your node. And that agent, what will do that, whenever a pod has to get created, what this agent will do, the kubelet agent will do that, the kubelet agent, it is going to refer to the CRI, container runtime interface, right? This is the CRI which would be running inside it. So consider it as a Docker which is running inside your Docker as a technology which is being used. So this CRI, what it will do that, it in turn calls the Docker, right? Docker, and the Docker is the one, sorry, the kubelet is the one basically which is going to create a pod, but just running a pod is not sufficient. Inside a pod, a container has to be run. So that's the reason what happened, that the kubelet is going to in turn call the CRI, and CRI is like a plugin, as we discussed earlier, that calls the Docker, and the Docker is the one which actually creates your container inside a pod, right? It's going to create a container, create the container inside the pod. Now, every pod will get a IP address, which will get an IP address. So every pod will get an IP address. Like, for example, here, this pod might get some IP address. Like, for example, it might get an IP address, something like 10.0. Or something 10.100.0.10. That is an IP address which will be assigned for this pod, right? And a container will get created, and this container, whenever you want to do any kind of a communication to any other container which is running on other pod, it uses this IP address actually, right? And how it communicates and everything, there are some network policies are there, right? By which what happened, one pod can communicate to other pod with some sort of network policies. What are those network policies and all? We will discuss it in later, not now. So we have to even understand about the networking stuff, what goes around within the Kubernetes cluster. We have to understand from very high level. And the second is important is that actually that each and every node, each and every worker node will have something known as a CNI, right? Correct, guys? CNI. CNI is nothing but what? Container network interface. So we know that there are some container network interface CNIs are there which are used actually, right? And what are those CNIs all about, and why it is used for having networking within your Kubernetes cluster? All such things we have to discuss in our upcoming session. But right now, what we are understanding from the very high level, that if one pod it want to communicate with other pod, so the pod to pod communication can happen via this pod IP addresses. So if this is a pod, right? This is another pod, and if this pod also has some IP address, consider that all these pods are belong to the same Kubernetes cluster, right? Then in that case, what happened, right? So consider that this having an IP address like this, right? They can communicate each other with the help of an IP address or with the help of a pod names actually, right? It can either communicate with IP address or with the help of a pod names. So both the ways it is possible for doing a communication between two pods, right? Now, so guys, now the point here is that actually, fine. Now coming back here, like whenever you want to run any application, so what the end user will do, that end user will try to create some kind of, he's going to construct some kind of a command like kubectl command like this. So we know that whenever we want to run or we want to create a container, we want to create a pod, basically we use a kubectl command with something like a run, something like a app server, some name, and then hyphen fn image is equal to nginx hyphen port something 80 something. He will try to construct a command line to create a pod, or else he can write a manifest file or a YAML file, .yaml file. He can create it to run the content. Any one method we can use to create a pod actually. So whenever using this method to create a pod, so usually what happened, right? The API server will come to the picture, and the API server will try to connect or will try to contact to some worker node where this pod can be scheduled. So as soon as the pod is getting created inside a pod, who creates this pod? The kubelet agent will create a pod. But for it to create a pod, there are many what happened that there are many resources are required, and also what happened, each and every pod will have its own namespace actually. Namespaces. So for example, it has a network namespace, storage namespace. These are the namespace which has to get created, guys. Right? So now what I'm trying to say here over here is that actually these are the namespace which will be there. And what happened, right? Your container which is running inside a pod, right? It has an access to all these namespaces. It means that whenever this container which is running, right, it want to do some operation using some networking, or it want to save something, right? These are the namespaces through which what happened that this container can do any kind of an operation actually, right? So now here what happened, right? Here we are talking about only one container inside a pod, but is it only one container we can create, or we can create a multiple container? We can create a multiple container inside a pod like this. There is no restriction that you should not create more than one container inside a pod. You can create many of the containers we can create inside a pod, but always a best practice that we always try to create only one container inside a pod. Don't create more than that unless and until it is really required. For example, whenever you want to monitor this main application app which is running inside this pod, right? Then in that case, this will act like a main car, right? Our main container, and one more container which we are going to create inside. This will be acting like a sidecar, where what happened, you will be trying to create a container where it try to do a monitoring for this pod, for this container. So whenever you want to monitor it, you try to create one more container which does the monitoring for this container actually. So this is a sidecar container, and this is basically used, or this is something like a helper function, or it is a helper function for your main container actually. It will be a helper, right? Sometime what happened, right? This container, the sidecar card container will never come up unless and until the main container comes up actually. So whenever a pod get created, first always make sure that the main car will come up, or this main container which is running inside the pod, right? That has to come up, that has to come in a running state. Then only the sidecar containers will get created actually. Otherwise, if this main container is not there, there is no use of running a sidecar container, right? So always that we always have maximum try to keep it only one container inside a pod, but sometimes we might need more than one pod. Yeah, you can run it, right? It is not recommended that, okay, you have a three-tier architecture, like where, like you have something like a web server is there, right? You have something like an app server, application server, or backend application server where, like all your business processing happen, or all your business logic is there, as well as something like a DB container, or the database, right? This is a three-tier architecture. Now we might say that, okay, Rajesh, can we have this three steps of your application, like web application, web server, app, and DB server? Can we run everything as a part of a single pod itself? Because you said that you can have a multiple container inside a pod, right? Can we have this? Yeah, you can have it, but it's not recommended to have all these three running as a part of a single pod inside a container, right? As inside a pod, right? It is not recommendable. So we will have a separate pod for web, separate pod for app, and separate pod for DB. So we will try to have three different pods rather than having only one pod rather having only one pod with running these three containers, right? It is not recommendable, right? So that's how, guys. So, and here, as I said, right, like whenever a pod get created, says along with that, there are certain kinds of namespace will be provided for this pod actually. And there are some examples like network pod, network storage kind of a namespace which are assigned for this pod actually. And all this contain inside this pod. Like for example, this is one container, this is second container, and third container. All these containers can able to access this all these namespaces which has been assigned for this pod actually. Am I clear, sir? So now the question comes, Rajesh, is the pod will get an IP address or is the container will get an IP address? Because we know that in Docker world, when you try to learn about the Docker, right? In our last series, when we try to learn Docker, always what happened, container will get, or whenever the container is getting created in Docker, this container will get an IP address. You remember that, right? Container will get an IP address. This is a container and this is some IP address will be assigned for this container actually. So container will get IP address here. Whereas in case of a Kubernetes, right, containers are not getting IP address. Instead, a pod will get an IP address. So whether this IP address is it used by all these three containers inside a pod? Yes, sir. All these three containers can use the same IP address itself for communicating, right? Within each container, like this is a container, this is a container, like how these two containers inside a pod can communicate each other. They can communicate each other by using a local host or by using, by using a IP like 127.0.0.1, right? That is a local host IP address, right? It can use that local host IP address like 127.0.0.1. It will be used between these pods, between this container to communicate within each other inside a pod. But whenever this pod want to communicate, or whenever this container want to communicate with some other container, which is a part of some other pod, then in that case, it has to use this IP address actually. It can either use a IP address or whatever the host name which is assigned as part of that pod, right? That can be used for communicating between these two pods actually. So how the communication happen between one pod to the pod, as I said, right, there are some network policies are there, guys. We will be understanding those network policies where we'll clearly get to know that how a pod can communicate with other pod, right? So in the container technology, when we learned, right, we know that one container can communicate with other container. You remember, right? How they can communicate each other, guys, because there is some kind of a networking is there between there. Like for example, some like a bridge network is there actually, right? And bridge network is that with the help of a bridge network, what happened, right? This container can communicate to the other container using that bridge network actually. Same thing as here also we have something like some kind of a networking, like it could be either bridge network or overlay network. Let's see what is that network all about. But just I'm saying that whatever we are using for the Docker technology, same thing, more or less same thing you'll be even using for your Kubernetes also. But here what happened, we have some advanced networking stuffs are available in today time where we are using some kind of a mesh, actual service meshes, and many kind of other things like English controller we are using, which is not used now, right? But earlier we were using it actually. And then like we have a gateway APIs are there. Those are the channels through which you can able to communicate from one pod to other pod, right? All those things comes as a part of the network topology, right? So we will try to learn about the network topology as well as network policies and all, guys. So that will be very quite interesting topic to understand about how exactly networking works within inside a node, inside a worker node, as well as within the entire cluster, right? How the networking works, we will try to understand in detail, right? Okay, guys. Okay. Now, a pod is the smallest unit in Kubernetes, right? Each pod, what is it, will be provided with the resources like IP address, can say even storage also, and network. Am I clear, sir? Okay. Now, Now, for the example, now, okay, fine. So we understood, okay, whenever you want to run any application, pod has to be there. Without a pod, you cannot literally run any of the application within your Kubernetes cluster. You cannot run, right? You have to have a pod actually. Pod is again, what is a pod? Pod itself is a resource, guy. It's an API resource which is already existing within your Kubernetes master, right? It means that your Kubernetes API server will manage all these resources, API resource. Like one among them is a pod actually. Using that API resource, which is now the pod, whenever the API server want to launch or want to run any application, it launches or it creates a pod with the help of something like a kubelet, right? Kubelet is the agent which will be running inside your nodes actually. With the help of the kubelet, what the API server will do, that API server can schedule a newly created pod which can create it, and inside a pod a container has to get created, and that container will get created with the help of a CRIs actually. That's what you will see that in every worker node. Like for example, if you try to take this as a Kubernetes cluster, assume that this is my Kubernetes cluster. So this is a Kubernetes cluster. In the Kubernetes cluster, we know that like we'll have a multiple uh, master node. Right now, consider that we are only having only one master node. So consider that this is your master node, right? And apart from that, you have many other worker nodes. Like for example, you have worker nodes like worker node 1, worker node 2, like that. So here in this diagram, guys, I'm just drawing only two worker nodes, right? So this is nothing but your worker node 1, or I'll just say node 1 and node 2, right? And now here what happened in the master node, we know that actually that we have a API server here, which is the main component of your master node. Similarly, in each and every worker node, we have something like a kubelet actually, right? Here in the worker node 2 also, we have something like a kubelet, right? So kubelet is nothing but it's an agent which will be keep running inside this node actually. Now, whenever the master node, it want to schedule any kind of a job which has to run inside your Kubernetes cluster, this is your Kubernetes cluster, then that API server, what will do that? It will try to contact to the node 1, that is not, but it will try to contact to the kubelet, right? To know about that whether the resources are available within that node. Yeah, it say that, okay, the resources are available, right? Then what happened, right? This kubelet will try to communicate with your CRI, CRI as well as a CNI, right? Because CNI is the main thing which you use for networking stuff, right? And here what happened, right? In your node, basically what happened, it will try to create one pod actually here. It will try to create a pod. The kubelet will try to create a pod, and the CRI will try to create a container inside a pod. So inside a pod, a container has to get created. That container will get created inside this pod actually. And this pod needs an IP address. So basically what happened, right? There is one more component is there in your worker node, that is number the kube proxy, right? So that kube proxy will assign an IP address for this pod actually, right? So who assigns an IP address, guys? The kube proxy. But if you ask me, does Rajesh, that the IP address will be assigned by the kube proxy or something like a CNI, which is there in your each and every node? Guys, it is actually CNI, but right now I'm just telling you the kube proxy. Let's see later what is the role responsibility of kube proxy with the CNI. We will try to discuss it later on. But right now, just consider that, okay, kube proxy is the one which assigns an IP address. But later you will see the definition will get changed, and I'll say something about the CNI, which actually assigns an IP address for your pod actually. That discussion we'll do it in some time later actually. Right now, from the very high level, you have to understand, okay, kube proxy is the one which assigns IP address for each and every pod actually, or each and every newly created pod, right? And right, that's how the pod will get created inside your node actually. Now the question comes that, okay, you said that Rajesh, pod will get created and pod will get an IP address. Fine. Now the first thing comes to mind, that why the concept of pod came into this Kubernetes. Because we know that ultimately your container is the one, guys, which actually runs your application. Here in this case, the container is not, but this is considered as the concept that you are using a Docker as a container technology, and CRI will call the Docker, and the Docker is going to create a container inside this pod. right? So this will be a Docker container, right? And we know that actually whenever an application has to run, the application has to run inside this Docker container only. And where that application exists, the application exists as an image format, right? The application exists as an image format. It exists under the image format in any of the registries. Like for example, like your hub.docker.com, where you have your private registry, where you have kept that image. So ultimately what happened, right? Ultimately what happened, right? During the creation of this pod, the image will be pulled from this hub.docker.com, and it will run, the image will get loaded into a Docker container, and the Docker will take care of running your application inside this container. It loads that image and try to run that image actually, right? So now the question might come here that Rajesh, in that case, what is the actual usage of having a pod then? Or what is the meaning of having a pod if everything we are running inside a container, right? Like why Kubernetes actually came with the concept of this pod? Why can't Kubernetes directly create a container and run the application or image inside a container? Why we have some concept, something like a pod which comes in between, right? So it is very important for us, all of us, to distinguish between what is a pod and with it what is a container. We have to first have a distinguish. We have to understand what's the difference. Then only we'll get to know that why the Kubernetes or the CNCF, they came with this pod concept actually. Right now we said, okay, Rajesh, everything we are running inside a pod, that is fine. But why we need to have a pod first altogether? Why don't we directly have a container itself actually? So that's a major question which will always come in our mind, right? Like whenever we have learned the Docker or everything, already we learned about the Docker and how you can Dockerize any application, right? And then like how we can run that application, right? That everything we have learned, and we also learned about something about the Docker storage, Docker networking, and also something we learned about the Docker Swarm, right? Where we can have a Docker as a in a cluster form where we can run a cluster form with the help of a Docker Swarm service. We have seen it and how to create the replications and all, how to monitor it. All such things we have seen it very clearly in Docker. Then all of this sudden, why this Kubernetes came with this concept of pod at all, right? So we have to have a clear understanding of this actually, right? We need to have a clear understanding. That's what, let us try to understand that little bit in detail. Like consider that there is no concept of pod. There's no concept of our code. Consider that this Kubernetes cluster, right, or is the Kubernetes for running any application, it directly creates a container. It is not creating a pod. Assume for some time that it is not creating a pod. Only it is trying to create a container to run this application. So how the things is going to look like when it only creates a container, not the pod, right? That we will understand first, and then later we can switch it to, okay, now we will understand like how exactly pod comes to the picture, what is the significance or benefit a pod is going to bring in, right? And that's the reason what happened, right? The Kubernetes is trying to create a pod instead of a container directly, so that the container will be in a protected mode, and the container will be inside a pod actually. So that significance we are going to understand in some time now, right? So guys, did you understood the problem statement? First of all, Karthik and everyone, did you understood the problem statement? Why we came across with something like a pod, and what is the difference between pod and container? That is what we have to understand now, right? Firstly, why we came with this pod? Okay, that is a problem statement. But what is the difference between pod and the container altogether? That also you have to understand, and consider for some time that pod is not itself is not there. We are only dealing with container. Then, if Kubernetes is actually creating a container, right? Whether the things are going to work out with container itself, or there is some problem with the containers only in this Kubernetes cluster, because we know that in a Docker Swarm, everything runs as a container and everything is easily managed, everything by the container itself. So if everything is running or smoothly in the Docker Swarm as a container, then why Kubernetes bought in some technology known as a pod, and or some terminology known as a pod, and inside a pod a container to get created, all such things, why it has brought in. So these are the some problem statements, or these are the concepts which you have to understand. So let us try to understand from the high level how this containers, what is the difference between pod and a container. So for, I think for me again, I need the same diagram, guys. So I need a Kubernetes cluster, like where we have master node here. Right now I'm just drawing only one master node, guys, but it will always be in terms of odd number. Like basically you will have either you will have a 3 master node or 5 or 7 master node. Those are the master nodes we'll have. Ideally, you will see in the organization, we'll be having 3 master nodes. That is the ideal way where we manage the high redundancy or high availability of your master node. But here I'm just drawing only one master. Consider that in the real time, you'll be having some three master nodes. And worker nodes, it depends upon your workloads, right? How many workloads you are running as a part of your within a Kubernetes cluster. Based on that, what happened that you will have number of worker nodes, right? Somebody has asked me in the interview, like how many worker nodes are there in your real time, right? So I say that actually it depends upon how many services we are running. Say, for example, if I'm running some 40 services, for 40 service to run, how much worker nodes you need it? So I might need some 12 worker nodes. Okay. What are the configurations of that worker nodes? You will ask. What is the CPU? What is the RAM available with that? How and is there any concept like a namespace which you are using? Yes. How do you have a namespace within your Kubernetes cluster? What are the different namespaces you use it actually in your project altogether? So those are certain very high level things which they want to understand what was your setup in your real time when you're working on the real time Kubernetes project, right? In your organization, he will try to ask and he will try to know it, because with that answer, he will get to know that, okay, what kind of a Kubernetes cluster you have worked on it, in which Kubernetes version you have worked on it, whether you are involved in managing the whole Kubernetes or nothing, but whether you have any kind of a knowledge as a Kubernetes administrator where you manage the whole cluster, or else and also like how well you are involved in doing all administrative activity, like for example you want to upgrade the Kubernetes versions, right? Or else you want to add some node, delete some node, like manage all the workloads what is running, manage all kind of authorizations or the security part in. So those things and all, right, when you're trying to explain about your entire Kubernetes setup, right, he will get to know about like in which on what level you have worked on it. And also like whether you are trying to do any kind of a deployments, those things and all, he will ask you what kind of a deployment strategies you are using it when you are having your Kubernetes cluster, right? Most of the time we will say that, okay, we were having the Kubernetes cluster in our cloud account only. Either it could be in AKS or EKS, how you're managing over there actually, right? What is the autopod scaler actually, whether you're having a horizontal autopod scaler, vertical autopod scaler, how the authentications of us happening over in your cluster actually. Those things and all, they'll start asking you, digging more into the interview, so that they want to know like how much you are aware of the Kubernetes system, and whether you are managing all this cluster effectively, and what are the real-time challenges or day-to-day activity which you're doing it actually. And also they might ask you like, tell us more about the recent issue which you have faced it, and try to first explain about the problem statement what you are facing and how the issue got fixed it, what was your contribution in fixing that issue. All such things will be asked in an interview actually. So when we are understanding about the basic aspect of everything, guys, and then like when you try to do some kind of a when you try to understand the end to end as well as all kind of issues, or even like the deployment strategies, suppose sometimes the deployments were getting failed, why the deployments were getting failed, like what was the rollback strategy which you followed it, right? Whether you're using some kind of a GitOps like Argo CD, are you using in the project actually? How do you manage the Argo CDs, everything, right? How do you do the deployment? What is the benefit you're going to get it actually if you're using Argo CDs or Flux CD? So those are certain things which they are very much interested to know, like what was your main contribution in this area. So based on that itself, your selection happens actually, right? So okay, coming back here, guys. Our problem statement was that actually instead of having a pod altogether, consider that this is my Kubernetes cluster where I am having some one master node and two worker nodes. And just for timing, consider that actually I am trying to create, or I'm trying to run some application inside your Kubernetes cluster. And timing, consider that this is your Kubernetes cluster, and Kubernetes cluster, everything is working as a as a as a container actually. Assume that it is running all your application as a container, not as a pod. So now let us see how it works actually. Now, guys, whenever we want to create or whenever we want to run any application, we know that many times many of the applications will be dependent upon the databases. Like for example, if you're building any kind of a front end app, or you can say that just like an app server. For example, consider that you are build some application where you're developed through your Python, through the Python language, you have developed an Python application, something like PyApp application, you have developed it. And this Py application, which is nothing but the main, your main application or the main business logic application, right? Or your main application where your entire functionality of your application, right, will be running as the PyApp. And this PyApp application, it might need some kind of a database, because ultimately when your application is running, it has to store some data. So the data has to be stored, everything into some database actually. And consider in the back end, you have some database. Say, for example, you have something like a MongoDB. So MongoDB is a database where what happened, right? Whatever the activity where your Python application is doing, or your backend main application is doing, it has to connect to the database, and to the database, what happened, right? This Py application will try to save all the data in this database actually. So this is a scenario, guys. And now you can understand that this Python application, it always depend upon the database to be available. It means that if the MongoDB is not there, if the MongoDB is not there, this Py app will never come up. It means that this application will stop working because it doesn't have any database which is available. So it means that always there has to be some kind of a connectivity between your application to the database. Am I clear, sir? Right, sir? Now, now the thing is that, guys, for example, consider that I'm running this application, like with the help of a Docker command only. I'm trying to run this application inside your Kubernetes cluster. For example, if you want to run the same application like Python or MongoDB, we know very well that how we used to run with the help of a Docker command, right? Like what I has to do, right? First, I has to run a command Docker container, run what is it, hyphen name. Suppose I want to run a MongoDB, I'll just say MongoDB, the name of it actually, and then like I will use something like a image name is something like a Mongo. What is it actually? Mongo colon latest, right? This is how. And there was some environment variable which I have to pass using hyphen e option. I'm not mentioning that. Consider that you are passing some option, hyphen e options, even for passing some environment variable when you're trying to create or when you try to run the MongoDB. This is what the command used to run it to create the MongoDB container. Same thing, whenever I want to run any kind of my Python application, you run a simple command like this, docker container run hyphen name, something like app server, and provide your Py app, something like Py app is an image name, and something colon 1.0 is a version, something. This is how you used to run it for creating this container. Right. So right now, guys, we are assuming that within your Kubernetes cluster, we have something, we don't have anything like a pod. We are only having container, and we are trying to run application with the help of a Docker command, because here Docker is a container technology which you are using inside the Kubernetes cluster. And through the help of this command, we are trying to create this container. So when you're trying to run this command, basically what happened, it has to create a container. So consider that when you're trying to create a MongoDB container, assume that it is trying to create over here. Like for example, here in the node 2, it will try to create this container. This is the container. It's not a pod, right? It's a container actually, which has been created in the node 2. Correct, guys? And here what happened, right? Your MongoDB is running actually. Your MongoDB is running, right? With MongoDB is running. Similarly, what happened, right? Here you are running the second command, which is Docker container hyphen name app server, and you are providing it. Here, what happened in this node 1, your app server will be running here. Your app server, but your majorly your main application, or nothing but your business logic application, which is the Py app, which will be running over here in this container. This is a container actually. So we know that whenever these containers are getting created, these containers will be provided some kind of an IP address. Like for example, assume that this DB container will get some IP address like 192.168.0.1. And for this app server, your Python application, which is running, it will get an IP address. The container will get an IP address like 192.168.0.2. Consider these are the IP addresses which have been created, assigned for these containers. So now we know very well that this app server, which is written in Python actually, it always expects the MongoDB to be up actually. So there is always a connectivity between your Python app with your MongoDB. So usually what happens in your application side, whenever a developer is developing an application, Python application, right? What he does that he will try to build a DB connectivity string, right? He'll try to do he will try to write a code in the code where you will be mentioning, okay, I need to do connect to the MongoDB. So he will write a DB connectivity code where what happened, it will try to check if there is any MongoDB is available up and running, try to connect it actually. Try to connect it. So usually what happened, guys, whatever the IP address which is there, right, 192.168.0.1, which is the MongoDB IP address, that will be binded with this Python app, because through this IP only what happened, right, the Python application will get connected to your MongoDB with this IP address and with some username and the password. It tried to have a connected to this MongoDB. Correct? So this is okay. So now what happened? Okay, this application was happily working, everything. So we are running this all these things in our production environment. Now suddenly assume that actually there is some issue happened where this MongoDB container will go down actually. It goes down means basically it becomes unresponsive due to some issue. There could be some kind of a server issue, or there could be some kind of a CPU or memory issue. Due to some reason, assume that this container goes down. Right? So what happened, guys? If this MongoDB, if it goes down, usually what happened, right? This app server, which is running here in the node 1, it will stop working, because ultimately what happened, the MongoDB has gone down. So this app server, it will try to check whether the DB is available or not, right? By just checking to this IP address of this MongoDB. It says that actually it try to check to this IP address. This IP address is not responsive. So what happened, this Python application, which is running inside this container, right? It understands that the connectivity of to this IP address has been lost because this container has gone down due to some reason. Now, once this DB goes down, even your app server will also go down. It will never work actually. It will stop work. So now what happened, right? Now the question comes that Rajesh, like if this MongoDB goes down, okay, now who is responsible? Who is going to be responsible for managing or maintaining or monitoring all these things? Because we are running all this setup, everything in a production environment, right? So we cannot keep one person or a set of people continuously to monitor everything in production environment, whether it has gone down or not. Assume that okay, you have set up some kind of alert notification, right? The alert might trigger and it might create a ticket for you saying that okay, this MongoDB has gone down. Okay, you might get some notification, but suppose assume that actually that you have kept some person who is always monitoring this cluster, and within that cluster he also tried to monitor all these containers, and suddenly he got to know that okay, this MongoDB has gone down. Now what that administrator will do, that he will try to he will try to recreate this container, or he'll try to create, or he's going to launch a new container. So assume that he's launching one more new container, a MongoDB container. He's launching a new one more MongoDB container. So this MongoDB container is created, fine. This same database has been, he has created, he has manually has created it. Who's created? The person who is sitting in the production moment to monitor, right? He would have created, got to know. But, and this newly created MongoDB, guys, it would have got its own IP address, right? For example, it got a new IP address for this, or a new IP address is assigned for this container, newly created container, which is something like 1.0, 192.1.0.3. Now the problem is that actually that this app server, it cannot do a connection to this MongoDB. It cannot do it because already some IP address was binded to this Python application or to this app server where it established a connection. Then what happened? This app server was communicating with this MongoDB. Similarly, now what happened? A new container has been created, but it has got a new IP address. It is not the same old IP address. It's a new IP address. Now this IP address has to be rebinded to your Python app or to this application. Then only what happened, this Python application or this app server will try to communicate with this model. So there has to be some human intervention should happen here, so that he has to make sure that some kind of a config change has to be done here, so that this app server will try to reconnect to this new database container, and it can start communicating. So here again, what happened? A human intervention has to happen. Without that, this app server will not come up. So here what happened, if anyone sitting in a production environment, he cannot do all those things, guys. It is not recommended to do that. And also you could make out that there is no automation over here where, like there's no automation over here where, like suddenly this suddenly this container goes down and some kind of a controllers are there where it try to understand, okay, this MongoDB has gone down. Okay, let me create a new container. Let me fastly create a new container and let me try to do a connectivity between this newly created container with this app server. like there is no control or there is no automation is available over there where all these things can happen, so that there should not be any kind of a human intervention, right? So such things is not available when it comes to the Docker. It means that even like, for example, when you know that in the Docker, we have something like a Docker Swarm. So Docker Swarm is basically, this is the service, guys, which you use for creating a Docker cluster, right? We can create a cluster within your Docker environment. And all kind of a high availability you can maintain. High availability and redundancy, all these features you can maintain with the help of the Docker cluster, which is through the help of a Docker Swarm, you can create it. But there also what happened in case of a Docker Swarm, it only checks or it only monitors the container which is running. Suppose due to some reason, if if there is any problem with the health check of this container, or else if this container goes down, so what this Docker Swarm will do, the Docker Swarm will create or it will going to launch a new container. But this rebinding of this IP address to this app server and all, the Docker Swarm cannot do it. Here again, what happened? The complete automation cannot be handled everything by the Docker Swarm. So this is the major problem when it comes to container technology. So you cannot achieve the complete 100% automation when any kind of an issue you face in the real time in the production moment. You cannot fix all those issues when if you are using only the containers. Then in that case, guys, how we are going to manage, or how we are going to come out from this problem then? So what they say that actually that, guys, what they say that actually, like, okay, fine, let us see that, let us do one thing, let us try to have a pod actually. Let us bring in a pod concept in the Kubernetes that might solve this problem, whatever you are facing in Docker container, right? So what is that problem? So I think I have to again draw a diagram. Multiple times today I have to draw a diagram just to explain this concept. So assume that this again, it is a Kubernetes cluster where you are having a master node and where you are having a worker node. Correct, guys? Now this is your Kubernetes master node. Sorry, master node. And this is your worker node. This is the worker node 1, or I'll just say node 1 and node 2. Right? Now, the same thing, whatever you are running earlier as a container by using a Docker container, now I'll try to do it. I'll try to run the same thing. I'll try to run this Python application and this MongoDB application, everything within your Kubernetes cluster with the help of a kubectl commands. So we try to run a command like kubectl run db server -fn image is equal to Mongo DB colon something latest something, or Mongo DB colon 1.4 version something, right? And we will use the same kubectl command to run this app server -fn image equals to, what is it actually? What we use, guys? Py app colon 1.0. So these are the two commands, guys, we executed in your Kubernetes cluster to have these two applications running as a pod in your Kubernetes cluster. Now we came up with something like a pod. Let's see how the pod will try to resolve the problem statement what we face in just when we are discussing only thing like a container actually, right? So guys, I hope that you are understanding, right, with me, right?
Yes,
Right,
sir.
guys?
Yes, sir.
Okay. Now what happened here, when you're trying to create this MongoDB, or you want to run this, you want to create a MongoDB pod actually. So now we are coming with the pod concept actually. So now what happened, right? Now the Kubernetes master will try to identify in which node I can run or I can create this pod actually. So it understood, okay, node 2 is the one where I can create or I can schedule the pod actually. So what happened here in your node 1, or sorry, in the node 2, a pod will get created like this actually. A pod will get created. This is the pod actually. And inside the pod, right? Inside a pod, a container will get created. But usually what happened usually it happens that when it comes to the Docker, because we are using a Docker technology, what the Kubernetes will do that, Kubernetes what it will do that, it will try to create a pod, fine. But inside a pod, it will try to create two containers. One container it will try to create, and the container name will be usually POS container. PAUSC, POS container, right? And other will be your main container where your MongoDB is running. So this will be your main container, like MongoDB container or your DB server container. So this is how it happens. So this is the pod ultimately, right? But this pod, inside a pod, a two container will be running. Right? Now is whenever a pod is getting created, so we know that certain namespaces are provided for this pod. Say, for example, namespace, guys, it is a separate topic which I'll be discussing in some time, or maybe after 2, 3 sessions, we'll come up with something like a namespace concept. We'll be learning. Just assume that namespace is something like it's like a virtual cluster within your main cluster. So assume that you need to have your own cluster within a main cluster or within your Kubernetes cluster. You can have one kind of a namespace. Like for example, you want to run some different environments. Like in case of in the same Kubernetes cluster, I want to run something like a dev environment, QA environment, stage environment, prod environment. I want to run all kind of environment in the same cluster. Then we have something like a namespace actually. So with the namespace, what happened? You can run a different kind of an environments in the same cluster. Like that, you can understand as of now, right? But we will go in detail about the namespace in a few after a few sessions. I'll come with this namespace, a separate topic actually, right? So this namespace, what it does basically, guys, whenever a pod get created, this pod will be assigned, a newly created pod will be assigned or it will be created under some namespace. Assume that I have a namespace, something like a Dave namespace. So this pod will be created under the namespace known as a Dave. Am I clear, sir? Right? You have some other namespace also. Some people might say that Raj, there is something known as a default namespace there. Yes, sir, there is a default namespace also there. If you don't have any namespace, like you have not created any namespace, then there will be some namespace with the name default. So whenever creating a pod, it will be created under the default namespace. But consider that I created a namespace on the Dave. Inside this Dave namespace, a pod is getting created. Whenever a pod is getting created, the pod will be created under the Dave namespace. Right? Now, after that, what happened, guys? This pod will be assigned or will be getting an IP address. Consider that IP address something like 10.0.1.10. Assume that this IP address will be assigned for the pod. Okay. So here what happened inside this pod, guys, there are two containers are getting created. First, the POS container will get created. After that, the main container which you are trying to create, right? Like MongoDB or nothing but your database container, that will get created. So Rajesh, this why this pause getting created? This is the default stuff which happens in your Docker actually. So whenever a Docker has to Docker will be used as a container technology, then what the Kubernetes will do that Kubernetes will try to create a pause container first, and later immediately the main container. So this will act like a sidecar container, and this will be like a main container. So what is the usage of the pause container then? Without a pause, can a main container like a DB container can run? Yeah, we will discuss all about this in some time now or else in next session. But just consider that, okay, pause is the main container, or sorry, pause is the first container will get created within inside a pod. After that, the database container or the DB container or nothing but the main container will get created. Now, Rajesh, whatever the namespace is there, there are many other resources are there. Whether all those resources are shared by all these containers, yes, sir. All these containers share the same thing. So it shares the namespace like day namespace. It shares the same storage. It shares the networking. It shares even this IP address also. Both POS container and database container both can share the same IP address 10.0.1.10 because this 10.0.1 it is not assigned to the containers. It is actually assigned to a pod. So pod will have an IP address, not the container. Whereas here in this case of your Docker container will get a IP address. Here what happened? Pod will get an IP address actually. Pod will be assigned a unique IP address actually. Clear guys? Same thing what happened when you're trying to create your applications, you want to run your applications or app server. So usually what happened, right? This app server, basically what happened, what the Kubernetes will do that Kubernetes will try to create a pod. Actually, it understand, okay, node one is a available node where I can create the pod. So what it will do that it will try to create a pod. The same story, we'll try to create a pod, right? And this pod will be assigned some IP address. right? The IP address will 10.0.1.20. That's an IP address will be assigned for the pod, right? And inside a pod, a POS container will get created, right? And after that, what happened, guys? Here, the main container will get created, where your Python application or your app server will be running here. Right? So while creating, we know that when the pod is getting created, it has to get created under some namespace. Since we are discussing about the Day namespace, let the namespace would be. So if I can, the namespace I can, in short, I can call it NS namespace. Here it is a Day namespace. Under this Day namespace, this pod is getting created. Clear, guys? Right? So now we know that actually that as per our discussion, we know that this Python application is dependent upon the MongoDB. It means that if the MongoDB is not available, this Python app will never come up. It means that this pod will never come up. So there's a dependency between this pod to this pod. Correct, guys? This pod to this pod. So what happened, right? Whenever this app server comes up, right, it expects the DB server pod to be available, right? It got to know that DB pod is available. So what happened? There is some kind of a connection DB string is there, through which what happened? It tried to connect. It tried to create a connection between this pod to this pod with the help of a IP address. With the help of IP address or pod name, whatever might be. So it means that this IP address will be binded to this app server. Will be binded to the app server, so that this app server know that, okay, whenever I want to reach out the database server, I want to refer or I want to use IP address. So this IP address with some default username and the password, what happened? This app server will try to connect to this pod where the database is running actually. Am I clear, sir? Is it fine? Yeah. Now the thing, yes, sir.
The username password of the database or app server?
Come again, sir. Be louder.
Yeah, it is the you said that username and password for the database server we are using to connect the otherwise from app
Yeah, yeah.
server.
Yes, yes. Because here what happened, right? When you know that when you're trying to run the database, so like MongoDB, right? You will also pass some hyphen E option. You pass some MongoDB username, MongoDB password, some default database like that. You pass some parameter, right? Same thing what happened when you're trying to run this app server also, you need to provide the details about to which database it has to get connected. So here what happened when you're trying to do it, we try to give some kind of a database name you're going to give it actually, not the IP address, because we never know the IP address, right? What IP address will be assigned for this pod, right? That we'll never know upfront, right? We can give the database name and the database name is your pod name. What are the pod name which is running, right? The pod name you can give, plus the username and the password also can pass it, so that when this app server comes up, right, it try to connect to this pod with the pod name and with that username and the password, it try to connect to this database actually. So that is what we call as a connection URL, connection string URL. MongoDB connection string URL will be developed or it will be implemented within your app server coding, right? If within app server code, it will be implemented so that it try to connect to the MongoDB server with the username, password, as well as with the host name or nothing but the server name actually, right? Or the pod name. That's how that's how this microservice or this but your Python app, right, which is developed, it will be written in that way. Clear, guys?
Yes, sir.
Now the question comes, okay, fine, Rajesh, this is running as a pod. Now pod has got an IP address, not the container. That you have to keep in mind. Okay. Now the question comes, Rajesh, due to some reason, this DB server or this DB server which is running inside this pod, right, inside this container, right, this is having some problem actually. It goes down. Assume that this goes down. Now, what the Kubernetes do, right, as part of managing the high availability or redundancy or something like that, right? What it do that basically it and also as per the policy, it checks if any kind of a container is going down inside the pod, there is something like a container restart policy is there. According to a container restart policy, if this DB server, which is running inside a pod, if it is going down, what the pod will do that, what the Kubernetes will do that, Kubernetes will try to restart this DB server. So whenever the containers are going down, guys, it's not like the new pod will get created. The same pod exists and the IP address also exists. Only the part is that actually this DB server will be restarted actually. And we try to do some kind of a correction so that this DB restart happen properly and this DB server comes up again. So in that case, what happened? If any kind of a downtime happens or if this DB server goes down, we know that Kubernetes by default will, according to the container restart policy, what it will do, it will try to restart this container, right? The container will get restarted. Automatically, what happened? This app server which is running, right? It tried to re-establish the connection and then it found the DB server has come up. Then you will see the high availability of this application which is running. It means that this never goes down, right? So here, what happened? The container are getting restarted, not the pod actually. Here earlier in this case, in case of here, when the containers are getting restarted or container goes down, so there is nobody to create the new container. Either the human has to do it manually, or else if suppose that you have some kind of a controllers, the controller will take care of creating a new pod, sorry, new container. But we don't have any such kind of a controller or something like, like which try to recreate or which try to launch a new container if this DB server goes down, right? There is no mechanism as such, right? But if you are bringing all these things into your Docker Swarm, yeah, Docker Swarm will take care, or Docker Swarm will always maintain high availability. It said that, okay, Rajesh, if the MongoDB container which is going down, yeah, I know how to restart. Means that I know how to create a new container. It will try to create a new container, and as part of creation of new container, a new IP address should be assigned. But the problem over there is actually how we're going to rebind this new IP address with this app server. That is a challenge. And that issue cannot be solved by the Docker Swarm. Docker Swarm will never do that kind of an automation. Who has to do it again? There has to be some human intervention happen where this thing should happen, should be taken care so that this application can reconnect to this newly created database and it can able to and it can able to do a communication, right? So this was some kind of a real-time challenge which you are having. Even though you are having a Docker swarm, still we have some kind of a challenge. And as I said, right, there is no automation. A complete automation is not available when it comes to the Docker swarm or when it comes to a container itself. But whereas here, when it comes to Kubernetes, firstly, what happened? Right, Kubernetes, what it will do that it will try to restart this container. So because there's a restart policies there already, which has been implemented for the pod thing, there's a restart policy there. According to that, it restarts the container. So when it is restarting, there is no change of IP address or nothing is happening over it because it's the same pod which will be available, it will be there. Only this container will get restarted. Okay. If this container get restarted, it's well and good. If this container is not getting restarted, even though it is doing multiple restart, ultimately what happens, this app server will go down because it never founds the database content to be up. So obviously it will go down. Again, what happened, right? You need to see the logs, event logs and everything that why this DB server is not getting started. Maybe what happened, right? It might need some memory or what are the CPU cycles which is required that might not be available in the node 2. Hence, what happened? It might not be getting restarted, or it could be going something like OOM memory, out of memory, or some issue might be there. Because of that reason, this content is not coming up. There could be some reason because of which the content is not coming up. But most of the time, guys, what happened, right? Whenever the restart is happening, we will always see in the real time also that usually the container comes up actually. Because sometimes what happened, the container get hanged. Sometimes some kind of a flush has not happened. But during the restart, some kind of a flush happens. All right. All kind of a cache, everything will get cleared. And freshly the container will get restarted. At the time, the containers comes up without any issue. So under that case, guys, you don't have to worry about this binding and all because automatically what happened, this IP address exists and it will, I mean, this IP address is still binded to this application server or this to this your Python app server which is running. Am I clear, sir? Now the question comes, assume that Rajesh, for example, assume that this pod itself will go down. This pod itself will go down. Now, then what will happen? So if the pod itself will go down, then in that case, guys, what usually happens that when the pod itself will go down, what the Kubernetes will do that? Kubernetes will try to create a new pod. It'll try to create a new pod like this. It'll try to create a new pod like this. And the same story, like inside a pod, it try to create this POS container, and it'll try to have the same database container created inside this pod. Guys, what is the timing actually? 1 second. Oh, today, like we took very long, right? Okay, so it creates a new pod actually, guys, with the same thing. Now the problem here is that actually that whenever it's create a new pod, obviously what happened, right, it's going to create a new IP address. Like for example, it's going to assign a new IP address for this pod, newly created pod, right? 1.10.0.1.30 actually. This is a new IP address which gets created or which gets allocated for this pod actually. Because if this pod itself will go down, and if there's no mechanism to make to restart this pod or something like that, if the pod itself will go down, then in that case, what happened? Your Kubernetes has to create. If I say always Kubernetes means it's an API server. So the API server is going to recreate a new pod actually, or it's going to create a new pod, and the new pod will get all its namespace, it gets all this IP address, everything. But this time it's going to create a new IP address. The same problem comes to the picture here again, that this IP address has to be binded to this app server so that this pod will understand and try to reconnect to this database using this newly created pod, with this new created pod. Now again, what happened here in this Kubernetes also, we don't have any kind of a automation where this can be done it. If you want to do it, some human intervention has to be there where the human has to go intervene and he has to where he has to rebind this new IP address to this pod, and then only this app server can communicate. So here what happened, guys, how we can able to overcome from this problem actually. So we can overcome this problem with help of a controllers, we say. Okay. So, and also there's something like a services actually. So we use the services. So there is a concept known as the services. We will come up very soon in our upcoming session, right? So we have to use the services actually, right? Services we'll be using, right? We'll be using the services. Right, and also like we will be using some kind of a controllers over here, and the controllers what we'll be using something like deployments is one of the controllers we'll be using it actually, guys. So what this will do that as part of it, when you try to create these pods under this deployment controllers, what the deployment will do that the deployment is going to create a service, and that service will have its own IP address. The service will have its own IP address. Consider the service is having like 10.0.10.100. This is the IP address of that service it is having. So now what happened that whenever the service is there, right? What happened? Firstly, you need to create a deployment. Under the deployment, what happened? You will be using some services. That service will have one unique IP address will be assigned. And whenever the pods are getting created, all these pods are added to this service. It means that this pod will become will be working under that service actually. It will be working under this service, right? So it means that assume that this pod, which is having this IP address 10.0.1.30, right? So this pod, which is created as part of the deployment, right, or as part of the particular controller, right? If this get created, this will be a part of the deployment, and what happened, right? This IP address or pods will be a part of this as an endpoint to the services actually. Now the point here is that actually whenever your application server, it want to communicate with your database server, how the communication happens means this pods app server, it has to always bind to a service actually, to the service IP address, not to the pod set, not to the DB server's IP address. It has to be always binded to the service IPs actually, right? And like that's how. And this service will always be available up and running. It'll never go down. So the service will never get restarted or something. It will always be available. And this is the IP address. It will be a fixed IP address. Will always be there for that service. So now what happened, right? Whenever the app server it want to communicate to DB server, how the flow happens means it try to send the try to send the data to your service, right? And that service in turn will try to send the data to this DB server, which is actually running inside this pod with this IP address 10.0.1.30. So this 10.0.1.30, it will be added like an endpoint to the service. So it understands that whenever any kind of a pod which is actually sending a data to me, 10.0.1.20, when it is sending a data to me to this IP address, that service understands that I have to read it data to this pod actually. So all those information will be a part of the service. That's how what happened, right? Even though this pod is getting restarted, assume that this pod will get killed. Assume that this pod will get killed. A new pod will get created. Assume that a new pod will get created. Like assume that this is a pod, new pod will get created, and this will get an IP address like 10.0.1.40. It gets actually. Assume that this is a new pod actually now. 10.0. 1.40. Assume that this is a new pod which has been created, right? With this new IP address actually. So guys, what will happen that this IP address will be added as an endpoint within that service actually. So here your application server, which is about your Python app, it need not to really worry under which IP address my database is running. It need not to really worry. What is the worrying is that actually it has whether whenever it want to send any data, it's trying to send to the IP address which is IP address of a service actually, and that service will take care of further communicating with that actual pod where your database is running. Right. So all these IP addresses, whatever they right, they have been added as an endpoint to the service. Hence, what happened, right? Always you will be seeing that there will be a high availability of this application because even though this pod will go down, a new pod will get started, and immediately this IP address will be added as an endpoint to this service actually. So in that case, what happened, right? A rebinding and all those issues is not there when it comes to Kubernetes. You need not to do any kind of a rebinding and all whenever a new pod is getting created, right? Those issues and all are solved with the help of this services, or we call it as a controllers actually, right? And there is one more kind of a deployments are there. That deployment we will be using it actually for creating this pods, right? We'll be creating these pods under some kind of a deployment. We might use a replication control replica set, or else there is something like a deployment. So we'll come across with all those controllers also, guys, in our upcoming session, where you'll see that all these pods are getting created under some kind of a controllers or nothing but the deployments actually. And the services, it will act like a simple, act like a load balancer. Simple in one word, it like a load balancer. There are different services are there. We'll be discussing all those things in our upcoming sessions. Right? So this is a kind of a full automation which you are trying to do it when it comes to Kubernetes actually. And the same stuff is not there in your container actually, in the container world. Hence what happened, right? Always, right, whenever we are trying to run any application as part of your Kubernetes cluster, it is always better that we run that application, guys. We run that application inside the pod, not as a container. So hence we understood, okay, pod has to be there because inside a pod, a container has to get created. Because why we are managing everything as a pod, guys? Because these services are controllers, whatever will come up, they try to add on they try to communicate everything as a pod itself into the pod itself, and pod has an IP address. So all these IP addresses are added as endpoints to the services, so that if any further communication happen between the pod to pod or between the user to the pod, anything happens, right, it happens via the service itself, right? So there are many services are there. One among the service is nothing but the load balancer, right? So using the load balancer service also, you can achieve all this complete automation. So that is what happened. We come across with something known as a pod. So pod is the deployable unit, what I discussed actually, and there is a resource known as a pod. With the help of a pods are getting created inside the worker nodes. Am I clear, sir? Right, guys. Now, coming back here, let us try to, guys, I'll take another 15 minutes more. I know it's a long time today I took it, but no, we started at 8:30, right? Sorry, 8:30, right? Yeah, it's, yeah. Let's see a few of the stuffs, guys, how we can able to see all those things. Like, for example, okay, let me first log into the master node, copy the public IP. पियो आवाज कम कर बेटा. Okay, let me log into my server, guys. Ubuntu at the rate. Give the IP address of your master node. Okay, I've logged in it, and I will log in to the worker node also. SSH-I Ubuntu at the rate. Give the IP address of the worker one, node one. Copy the public IP. So you're logged in on both the nodes, like master node and the worker node, right? If I try to do a kubectl get pods, you see that, guys, there are no pods are running. I deleted all the pods, right? Now here, suppose assume that actually like I'm running some, I want to run some pod, or else I want to create a pod action. So what I'll do that, I'll just say kubectl run. I will give something like an app server. Okay, I'll give some image name is, or else web server, sorry, web-server. And I will give the image name as -image is equal to nginx. right? When I try to do a kubectl get pods, you could see that this web server is a pod name which we gave it, and it is running, right? So when I try to do a kubectl describe pod and specify the pod name. So guys, here you could see that this is a pod which is created and this is a pod name, and the default, the namespace where it is created is a default, right? And then the priority and the service account, we'll discuss all this later. Here you could see that by default some label is assigned for it, and this is the IP address for your pod actually 10.44.0.1, right? Now when it comes to the contents inside this pod, like what are the contents get created? But if you see it very like carefully, only one pod is there, guys. That's an Nginx pod which is running inside this container. But as we discussed, right, there is some one another container will be there and something like a pause container that would be running actually, right? But it is not going display over here. It will never get displayed over here, guys. If you want to really see it, you can go to the node one, and then like you can just run a command docker container ls. Here you could see that this is your main web server container which is getting created over here. But along with that, can you see there is something like a pause container also created here? See? And you could see that it just got created a minute ago, right? And if you try to do it again, you could see that actually that both these containers are getting created. First, the pause got created, and afterwards your web server container got created. So these two containers are part of the same pod actually, even though it is not displaying over there when you try to do a describe. But here, when you try to do a Docker container in that node, right, you could able to see that the pause is getting created. If you try to kill that pod, kubectl delete pod, what is the pod name? Web server, right? The pod is getting killed. And if you go back here, 1 second, guys. If you go back here on node one, if you go back node, and if you try to do a Docker container ls, you could see, guys, that pause is also gone, and even your Nginx is also gone. So nothing is shown over here, right? So with that case, we can clearly know that, okay, even that pause content got created, that is a part of the web server pod itself, actually. That's how you can able to prove it, actually, right? Now, the thing is that, guys, see, when we try to create the container by using this command, we try to create a container by name web server, right? When I try to do kubectl get pods, you could see this container is running. I mean, sorry, this pod is running. Now, when I try to delete this pod by using a delete PO, it got deleted. But have you seen that whether this any kind of a new container or new pod is getting started again, or whether new container kind of pods are getting started? No, it's not getting started because here this pod is running. Okay, it's a standalone pod which is running, but this pod is not been controlled by any controller. There's no controller which is available. Where what happened, right? This container, sorry, this pod is running inside this, inside that controller. It is not running. Hence, what happened? There is no restart or there is no new pod creation happens if that particular pod is not being controlled by any controller, right? That's what we are not able to see it actually. Correct, guys? Do you agree with me? Right?
Yes, sir.
Suppose you say that, okay, Rajesh, I want to create a pod, but that has to be under some controller. So, okay. So if I take an example of this, okay, Rajesh, there is something like a deployment is one of the controller. I want to use this deployment as a controller so that I can create a pod inside this deployment controller. How to do that actually, right? You can just use a command kubectl, what is it? Create. I'll use the deployment, the controller name is deployment. I'll just say deploy. Okay. And I will give something like a same thing. I'll use something like a web server. Okay. And you have to pass the replicas, guys. You can pass replicas as 1 or 2, or I'll just pass as 1. And I'll give the name as image name as Nginx. See now, they could see that you are created a pod. So if I try to do a kubectl get pods -o wide, you could see that, guys, it has created a pod actually, which is running inside the node 1. But you could see that when a pod is getting created, it has to get created with this name. But along with that name, you could see that actually it has even given some other number also like this actually. right? What are these things and all we will see and discuss later, guys. When I talk about the controls, right, I will discuss more about this. But right now, just understand, okay, it has actually created a pod by assigning some values to it actually, right? Correct? Okay. Now, how do you verify it actually? So, for example, let me run the same one more container like kubectl run. Uh, this is I gave the name as a web app, right? Web server, right? I'll just something like I'll just give the name as app server. I'll just use the same image like Nginx itself. Let's run one more container here. Sorry, one more pod here. So if I try to do kubectl get pods, you see that actually there are two pods are running. One is an app server and other is a web server, right? But you could see that actually that you created this web server with the help of a controller, right? But whereas this one you plainly created it. Now, how do you verify whether which of these pods are under some are being created under some controller, something like that? So what you can do that you can just say get kubectl describe what is it actually pod and give the pod name like app server. I can just say pipe it to grep hyphen I controlled actually something like that. So it see that it is not being controlled by any controller. The same thing if I try to run this kubectl describe pod, or if I just say pod and give this pod name, enter. Can you see, guys? If you try to do it, can you see it? It is controlled by something as a replica set, right? And if you try to run the same, I mean, what I'm doing here, I'm just trying to describe pipe to grep hyphen I controlled. See, it has been controlled. It has been controlled by a controller known as a replica set. Right? Now, what is the meaning of this? Say, for example, due to some reason, the pod get killed. If I try to do a kubectl get pods, you could see that actually that assume that this pod is getting killed, or else you try to delete that pod. I'll just say kubectl delete pod, pod space and specify this pod name. So this pod is getting deleted, but if you try to do a kubectl get pods, you will see that automatically a new pod will get created. With the same name, see web server -848, only this name will get changed. Earlier it was G7F5V. Now you could see that N9SLM, some name is there. Some naming convention is there. But it's the same pod actually. Because you try to delete that pod, according to that controller, what the controller do that, it will try to recreate a new pod actually to maintain high availability. So hence what happened, according to this diagram, whenever a pod is created under some kind of a controller, then what happened, guys, this pod is maintained or it will be monitored by that particular controller. Whenever anything happens to a pod, whenever the pod will get killed, automatically a new pod will get added up or a new pod will get created. Whereas here, if you try to delete this pod, app server, we know that we will never get, a new pod will never get created, right? When you try to do a kubectl delete, PO pod or just a PO app-server. So it has been deleted. But when I try to do kubectl get pods, you will see that it will not get created at all, right? Because that app server is not being controlled by any kind of a controller. Am I clear, sir? Okay,
Yes,
guys,
Rajesh.
that's all about, yeah, that's all about this, right? And yeah, sure. Okay, if I want to delete all the pods, I'll just say kubectl delete pod hyphen all. Can do that, it will delete the pod. So if you delete the pod means what happened, guys? Say still a new content will get created because it is under the control actually.
How to delete the
Right? How do you delete it?
control?
Sorry? You have to delete that controller, yes. Correct, guys? So now, we will be discussing more about this. Where is it actually, guys? Yeah, you will be discussing more about the service and deployment. So in our upcoming session, guys, like what we need to majorly cover, like one is I will be discussing about the, we started with a pod introduction right today, and we will try to discuss about the next session will be something like a different states of the pod or different stages of pod, like how we have different stages of uh, Docker container, right? Similarly, we have a different stage of pods and the different types of pods. Even you have to discuss even this also. Different states or stages of pod and what are the different types of pods are. Like we have something like a init pod, we have something like ephemeral pods. We have a different pods are there, right? Like we'll be discussing about that in the next class, right? And also we need to discuss about the Kubernetes microservice architecture. So this is also important. After this, what happened, guys? After this, we need to we will be discussing about small topics like namespace. We'll be discussing about how to upgrade the nodes or how to upgrade the Kubernetes versions, and also we need to discuss about the taint tolerations. All right. Those are small topics which we have to cover. Once we cover up, like we have to start an important one, like Kubernetes services, right? Under the Kubernetes servers, what is it actually? You have something like a cluster IP, node port, and load balancer actually. So load balancers, like we'll be discussing about generic load balancers as well as we'll be discussing something known as the Ingress load balancer. Guys, this Ingress load balancer, we will cover it, but in the now the Ingress load balancer has been decommissioned, means that they will try to support up to some particular version. After that, they will remove that Ingress load balancer. It is will not be used anymore in the projects. And then like we have something as a gateway API. This also we will be discussing. Okay, gateway API as part of your types of pods controller. Majorly, we have something like replication controller, which is not used, but still, yeah, I mean, just for to start with, what are these controllers, right? I have to discuss about the replication controller. We have something like a replica set. We have what is it actually? Deployments. Deployments. We have a daemon set, and we have something like a stateful set. So these things we will be discussing, guys, in our upcoming. Like you could see that I think around 2 to 3 sessions, or more than 4 5 sessions, we'll be discussing only on these things only, right? Okay. So next class, guys, we will try to cover up these things actually. This at least these 3 things we will try to cover up in tomorrow session. Okay. Okay, guys, that's all for the day today. Okay, we will meet tomorrow again. Maybe tomorrow morning, guys, I will have to go to office. I will not be able to take tomorrow early morning. I'll plan to take tomorrow is Friday, right? I'll try to take evening only. Saturday, I will try to take little late today, late at the morning time, like 11 or 11:30 morning. Saturday, I will take it. Evening also, we will have one class if possible. If not, then Sunday morning and Sunday evening, we will have 2 sessions actually, right? We'll try to cover up as much as possible this week, right? Okay, guys. That's all for the day today. Thank you all. Yeah.
Control the power.
Yeah, you have to just whatever we the command we use, right? The create right here. You have to just use delete actually. Yeah. Uh, okay. Now I'm gonna try to do a cube thread. Get pods. You could say nothing, sir. Okay. This is a command. Cube thread delete, deploy, and specify that deployment name actually. Okay. Okay, guys. So yeah, that's all for the day. Okay, we will meet again tomorrow evening. We'll meet it. Hmm? Thank you, Andar. Let me stop the recording.